Welcome back to Elemental. Today on our show, we have invited an expert to discuss Group 4B of the periodic table with us. The element being explored includes titanium, zirconium, hafnium, rutherfordium, cerium, and thorium. Oh, here comes our guest now. Hi, thank you for having me on the show. I'm thrilled to teach the audience today. They weren't able to make it due to issues within the family. Well, we're just excited to have you. So will you give us an idea of the of the elements as a whole? Of course. Family 4B are all transition metals. They have 4 valence electrons. Their group is easily heated, which explains why they aren't at the show. Their chemical properties are just so different from each other. Oh. What are their melting and boiling points? Well, zirconium has a boiling point of 4682 Kelvin. Hafnium has a boiling point of 4876 Kelvin. Rutherfordium is the most reluctant to give information out on his measures. I couldn't obtain that data. As for the other elements, titanium has a boiling point of 3560 Kelvin. Cerium has a boiling point of 3699 Kelvin. And lastly, thorium has a boiling point of 5060 Kelvin. Yeah. Fascinating. What are their phases and densities at room temperature? Well, I have that answer. The phase of zirconium is solid and its density is 6.52 grams per cubic centimeter. The phase of hafnium is the same and its density is 13.3 per centimeter. Rutherfordium refused to give this information. Also, cerium has a density of 6.55 grams per centimeter. Thorium has a density of 11.78, and titanium has a density of 4.54. Rutherfordium sure is stubborn. If I may ask, what is each element's atomic number and atomic mass? Oh, the atomic number and mass for zirconium is 40 and 91.224. The atomic number and mass for hafnium are 72 and 178.49. The atomic number for rutherfordium is 104, though its mass is unknown. The atomic number and mass for titanium are 22 and 47.88. The atomic mass and number are 58 and 140.115 for cerium. The atomic number and mass for thorium are 90 and 232.038.1. Oh, I see. What are the oceanic and crustal abundances? The crustal abundance for zirconium is 1.65 times 10 to the second power, milligrams per kilogram, parentheses shown on video. The crustal abundance for hafnium is 3 milligrams per kilogram. The crustal abundance for titanium is 5.65 times 10 to the third power milligrams per kilogram. The crustal abundance for cerium is 6.65 times 10 to the 1 power milligrams per kilogram. The crustal abundance for thorium is 9.6 milligrams per kilogram. The oceanic abundance for hafnium is 7 times 10 to the negative 6 power milligrams per liter. The oceanic abundance for zirconium is 3 times 10 to the negative 5th power milligrams per liter. Both abundances are shown for rutherfordium. The oceanic abundance for titanium is 1 times 10 to the negative 3rd milligrams per liter. The oceanic abundance for cerium is 1.2 times 10 to the negative 6 power milligrams per liter. The oceanic abundance for thorium is 1 times 10 to the negative 5th power milligrams per liter. Rutherfordium doesn't seem to have much of a history. Why don't you tell us more about their past? Sure. Here are photos of each. The symbol of zirconium is ZR. The symbol of hafnium is HF. The symbol of rutherfordium is RF. Zirconium got her name from a Persian word meaning gold-like. Hafnium got hers from the city of Copenhagen in Latin. Hafnia Rutherfordium was named after the physicist Ernest Rutherford. Zirconium was discovered in 1789 by Martin Heinrich Klaproth in Germany while studying the mineral argon. Hafnium was discovered in 1923 by Dirk Koster and Charles de Hevesy. They were studying the arrangement of zirconium ores when hafnium was found. Rutherfordium was discovered in 1964, though the originator is uncertain.
Oh, so have you witnessed any of their reactions? Yes, in fact I have. Zirconium and hafnium dissolve in hydrofluoric acid. They do not react with water or bases, though with oxygen, zirconium, hafnium, and rutherfordium may burn, becoming a fire hazard.
Wow, thanks for clarifying. Lastly, will you tell us on their electron configurations?
Absolutely. Thanks for having me on the show. And I'm glad that we could teach you how to do things.